Hello and welcome to part 2 of this series. Now we actually look at what we can do with the infrared data that we've collected. So the objective of this project is to open up some remote control possibilities. So as you know that a remote control can actually control your devices such as your TV, your set-top box and so on. If you wanted to remote control one of your devices with your Arduino, you could optionally modify your device and maybe wire up the Arduino to all the front panel buttons, but that's effort. That's why remote control is so lucrative. So the first thing you'll probably need that you probably don't have lying around is an infrared LED. So where did I get my infrared LED from? Well, I didn't buy it. What I did was I disassembled old remote controls, which have since become dysfunctional or not very useful, and or disassembled remote controls for PC tuner cards because I never use them. So I've got a whole stack of PC satellite and terrestrial tuner cards. They come with crappy under-functioning remotes which don't work with most of the software that I'm using it with, so what's the point? Let's just go and cannibalize it. So carefully desolder your infrared LED. You will need a resistor with this LED if you're driving it directly from the Arduino pins, because the infrared LED does not run at 5 volts and does need a bit of current limiting. One thing to be aware of is that infrared LEDs have a smaller forward current than visible light LEDs, so you will have to choose a slightly bigger resistor. Okay, so from the previous part we have arrays of data which indicate whether the pause between pulses should be short or long. So what can we do with it? Well, we write a function that actually beeps out the code. So using the Arduino tone function, I've written a function which accepts the particular button array base address and then uses the array to generate a pulse train sequence which resembles what was originally transmitted by the original remote. Now, due to Arduino timing issues, you do have to tweak delay microseconds quite a bit. So what I did was I programmed it up with one particular button to emulate, and I pointed it towards the actual receiver and got it to transmit in a loop, and I kept debugging the program by changing those variables ever so slightly until the pulse train from the original remote and the Arduino itself overlapped. So that indicates that both of them are transmitting identical signals. So once you have one of these functions, it's easy to adapt it to an application. For the first demonstration, I have, again, one of my favorite devices. This time it's a free Arduino. This one is a Arduino Demilanovi compatible board. This one was built from a kit, but it doesn't really matter. Any Arduino ought to do. And a different LCD keypad shield. So this looks relatively similar, but this one has been modified. It has an infrared diode sitting on analog port 1, used in digital mode though, and a resistor to ground. So that forms the transmitting element, all in one. Nice and neat. So let me show you what this can do. So without actually interfacing it with anything else, I'll just boot it up and show you the screen. Hopefully you will be able to see this. So it says all in sat remote mode, send button. So I can send individual buttons, I can set the LCD backlight, and I can run what I call B-scan macro or blind scan macro. So this is one of the advantages of such a device. You can actually program it to send a macro. So it sends buttons over and over and over, non-stop, with a predefined gap between the buttons. So this allows you to automate things, in this case blind scanning, which I will get to in a minute. But let's show you a live demonstration of this working. Okay guys, so here is my setup. I've got a digital satellite box which I had actually captured the remote commands from. I've got this screen showing capture from a digital capture card which captures from the analog output from this box, and I've got my little remote emulator. So you can see I'm in mode send button. So if I select, say, send button, let's try sending button let's try menu if I can find it. Menu. Okay, so what I've got to do is, unfortunately because the distance is quite large, I've actually got to point it at the box and then hit send. And there we go, we have the menu. So now I can select maybe exit. So let's find exit. Where are we? Exit, there we are. Point it at the box and press the button, and lo and behold, we've exited. So already I have shown that there's some sort of preliminary controllability. Now the interesting part, let me get it to send what we call blind scan macro. So the first thing is the box has to be turned off for blind scan. So now it is off. What I do is I put the sender right in front of it and I press the button to make it go, and watch what happens on the screen. The satellite box starts up. It enters the menu, it chooses install, it goes into blind scan, and it blind scans the first satellite. So as you can see, it's running its own macro. It'll do this over and over again. So what's the use? Now, I'm getting a little bit into satellite TV at the moment, and there are some transient transmissions on satellites which only last a very short time, and their purpose is to link, say, a remote site to the main studio for maybe breaking news or some sort of transmission from archives. And these transmissions are called feeds. They only happen every so often, and you can only catch them if you are trying to gain access to the feed at the same time as it's being transmitted. So what I do is I get this satellite box to continuously blind scan to acquire the parameters for these feeds, so I know what sort of frequency, symbol rate, FEC, and also what sort of PIDs are being used by the feed transmissions, so that I can tune in and watch these feeds. You can gain access to a variety of interesting transmissions on feeds, including unedited footage of crime scenes and reports on the field. You can actually see broadcasters preparing. You can watch sometimes V8 supercar races without ads, with commentary but without any breaks. You sometimes get breaking news from Parliament House. You can get streamed worldwide events like the royal wedding that came through from the BBC uncensored without the Channel 7 commentators. So this sort of thing can be quite interesting and can be quite useful if you can see an application for it, which I can. Well, there you go. That's one application. So let's move on to another one. So the second application involves, yet again, another Arduino board. This is a different one. This one I had also programmed with a different program, much the same idea, and an Ethernet shield. This is actually a DF robot Ethernet shield with a WIZnet 5100 controller, which makes life a little bit easier compared to the one with the ENC 28J60 controller. And I've hooked up a little infrared LED on just one of the ports again, and what we have here is essentially a internet connected remote control. So now I can go and control this particular satellite receiver using a browser. Now, why did this come about? Well, what happens is, in my room I have my satellite boxes stacked up, and when we're watching feed transmissions, what I find is that the corrupted, garbled data which we sometimes get from the feeds crashes any digital decoding applications, but they seem to work perfectly fine on set-top boxes. So in order to control my stack of set-top boxes, it's relatively difficult to get a remote and manually key it in. It's much easier to be sitting at the computer and controlling it from a browser window. So I'll hook this up and I'll show you it in action. Some of you may have already had a play around with this in my internet live streaming satellite test, which was a proof of concept. Okay, as now you can see I have it ready. The system here is actually showing the output from the capture card, and this little window here is actually a browser window which shows what my remote control is displaying. So as you can see, it's laid out similarly to what the original remote control is. So I can actually go and click one of these buttons, such as menu, and lo and behold, up comes the menu. So if I click exit, out comes the exit, and I can bring up the menu, I can scroll between channels, select OK. I can do everything that you can normally do with a remote through the web. So if I click menu, you can see the menu pops up straight away. If I click exit, it disappears. So there you go, an internet connected remote control. So there are a few considerations for you to think about when doing something like this. The first is this web page that is used to create that remote control interface does actually require quite a bit of space. This very simple layout on its own consumes almost about 4.5 to 5 kilobytes of the 32 kilobytes that are available on the actual Arduino. The other thing is that while there are 32 kilobytes of flash and you can use ProgMem to access it, there is actually not that much RAM. So RAM is usually the major problem. In order to get efficient use of the Ethernet interface, you do have to buffer up your data and send it send a buffered amount of data. That way you avoid the overhead of sending multiple packets. So initially I had written a single byte every single time to the Ethernet interface, 1 byte at a time, and what happened was we ended up with heaps and heaps and heaps of packets and heaps of overhead. So in order to reduce this, you need to buffer your data, and that also costs quite a bit of our precious RAM. There is only 1 kilobyte of static RAM on this particular board, so use it wisely.